Thing is, in order to test my schematic, I should take that schematic or that symbol which already I have created. Same process, press I for instance, go to the library which you have created. So this is the library which I have created. Click on the cell. Already INV1 symbol exists. View name should be symbol here. By default, view name is symbol. Select your schematic, place here. So this is your symbol which you have already created. I0 is the instance of invert one. Okay, like that you can create many instances of your schematic. You want one more, keep here. One more, keep here. Okay, the same thing will be instantiated. Now click on add instance. There is one library called as analog lib. Analog lib contains all the voltage sources which are required. So cell name is VPulse. Okay, so VPulse is the cell name. Take VPulse, click here, go to the properties of the VPulse. You can see many parameters here. Voltage 1 is 0, voltage 2 I can make it as 2.5. Don't give any dimension, just give 2.5. Okay, it is not taking. Don't give any dimensions. Voltage it will take automatically. So voltage 1 is 0, voltage 2 is 2.5. If you are choosing 1.45 nm, then supply will be again less, 1.25, 0.8. Okay, so like that it will be changed. Period, select a sufficient period, say 100 nanoseconds. Waveform, delay time I can give 1 nano, rise time 1 nano, fall time 1 nano. Pulse width, period is 500, so you can 50 nanoseconds I can make on time in that 100 seconds. So these parameters are important. Pulse width 50, period 100. It is up to you so to give it, but these are typical values. Delay, rise, fall you should give. Okay, then connect, take a wire, connect this to input. Okay, if you click on symbol, you will get one rectangle here. Within this rectangle, none of the components should come. Okay, none of the components should come. Then next, click on I again, analog lib. So you have one cell called as VDC. So take VDC. Here VPulse, here VDC. Click on the properties. So for VDC you have to give only the DC voltage. So I can give 2.5 volts. VDC means it is fixed. It is for VDD connection. Okay. Take a wire, connect it. Okay. Then important that you connect positive of VDC. Don't connect this negative to the power. Okay. Then click on add instance. Ground. Connect the grounds. You can make one common ground or you can select multiple grounds, no problem. Okay. Then there is a one output I have to take. You can attach a capacitive load and take the output, or just click on pin, add pin, make the output pin. Vout 1 I have already used, Vout 1. So use some another pin, Vout 2, output pin, keep it here. It should be above, outside this rectangle. Take a wire. So this is to tap the output. You can also connect one capacitive load and take the output also. Capacitive load represents the load of the next stage. If you are doing that, that is also very simple. Add instance, select the capacitance, put the load, keep here. That will not change any. Okay, simple it is. Then ground we have connected, so all connections we have done. Okay, output we have provided. Okay, then pulse source and this one. Click on check and save. Observe the log file, no errors. Then click on launch EDEN, analog design environment. Launch analog design environment EDE. Click on say setup. Okay, model libraries. Click on setup model libraries. Click. You will observe that home install foundry analog 180 model spectre is there. 180 nm is there. If you are using 45 nm, same thing, instead of 180 nm 45 nm will come. So you have to check, add that. Okay, now no requirement to add it. Click on OK. Let me show you transient analysis. Click on analysis, choose transient, say 1000 nano, because 100 nano I kept for 1 cycle. I want to see the output for 10 cycles. So I can select 1000 nano. Accuracy can be moderate. You need not do any other corrections. So transient analysis came into picture. Very important step is click on outputs. Click on outputs to be plotted. Select on design. So here I am selecting output wire, selecting input wire. Don't select this rectangle. Okay, outside this select output, select input. They will come in your AD as soon as you select them. So this is the output and this is the getting it. Click on simulation. Okay, so simulation will happen for you. Click on split windows. If you split it, you can observe when the input is high, output is low. Okay, when the input is low, output is high. So this is transient simulation. You can also do, apart from this, other analysis. Choose DC analysis. Choose DC analysis. Okay, click on component parameter. To do the DC analysis, you have to click on component parameter, select component, DC analysis, component parameter, select component. Then when you press on select component, automatically cursor will come to schematic. So click on the pulse source. Click on the pulse source, it will show you variety of options. I have to make it DC voltage because I want to do a DC analysis. So this will be swept. Okay. Then click on the, so you can see component is selected here, /V0, parameter is DC. Okay, sweep range it will ask. You can either click on logarithmic or linear. Okay, the sweep range can be, say, 2.5 is my voltage source, VDD. So I can select this from 0 to 5. So from DC will be swept from 0 to 5 volts. So output will be plotted for input of 0 to 5. So what I'll get, transfer characteristics I'll get from this. Okay, points per decade you can give 10 or 20. 10 or 20, say okay. You can select linear first, let us see. Like voltage source, you can give an option of step size, like how much interval I should have within 0 to 5. Then click on outputs again. Click on output. This is the window for the output. Okay, this is the window. So you can see the DC transfer characteristics. Okay, Since the step size I have given too much, you will see this graph like this. Otherwise, if you minimize that step size, it will resemble the inverter characteristics. So this is for transient response, this is for DC response. Close this. You can also choose the AC analysis also. AC sweep variable can be frequency 1 to 1 gigahertz or 10 gigahertz. You can select the sweep. You can make the sweep as logarithmic, points per decade 20. So this is AC analysis. Okay, it will plot output against the frequency, output voltage with respect to frequency. Don't go for any kind of specialized analysis. Okay, start to stop frequency AC analysis that will appear. You can also save the state here. Click on a session. Okay, save state. So every time I need not do these things, transient AC, DC. You can save this state and say give one name, save as state 1. Okay, you can add your USN here to indicate that it is yours. Say OK. It will be saved for you. Next time when you open it, you can directly click on launch, ADE, session, load state. Okay, so already this one is available, your library is available. You can select your this one and load the state. I think state 1 USN. Already the state name is present here. So directly you can see transient DC, AC, they will come. Click on this run for simulation. Okay, so this transient DC and DC will be available for you. Getting it? So you can do this process.